Login accepted.
Okay, hello, welcome everybody to my talk. Your tests are code 2. My name is Achim Wiedemann. So the agenda for today is going to be, first I'm going to give you some context, then I'm going to go over some testing theory. Then the biggest part is the practice, and yeah, that's it basically. So let's start off with the context part. So I'm a software developer working for Bosch since 2019, currently working for the e-bike project, which I find very interesting because you actually have to do with real physical things. I'm from the southwest of Germany and I love music. I'm a drummer and also love nature. And I'm a little bit obsessed with usability as well. So the project that I'm working for, the One by Cloud, is the platform for Bosch's new generation of e-bikes, although that's kind of not accurate because Bosch doesn't produce e-bikes themselves. We just produce the components like the drive units or batteries and stuff like that, and then we sell that to the manufacturers and they integrate that into their e-bikes. So the backend we built for that system has several user groups or target groups. So for one, it's the factories, so the manufacturers that produce the bikes. They use it to get firmware for the components to flash them initially when the bike is made in the factory. We also have a group that is the dealers. So they use the system for bike diagnosis, for example, or features for the customers like service book. So if you do maintenance on your bike, you can plug that basically into a computer and then you can get some diagnostic information like you would get with a car. And then the last user group is the end users themselves, so the people who buy an e-bike. They can actually download an app from the App Store and then use that app to connect it with their bike and then have functionality like navigation or activity tracking, so record all your trips. Also there's things like firmware over-the-air updates for your bike components, or also you can just tweak like your motor settings and stuff like that. And it's more stuff to come, so this will evolve over time. So as you can see, we have lots of different target groups, also internally, of course, in Bosch themselves as well. And so we're mainly an integration project. And our services are offered mainly in the form of web APIs. We also have some asynchronous processing with Kafka and stuff like that. But mainly our APIs are web APIs. And yeah, our main challenges are this like diverse group of stakeholders or customers, and then of course not to break stuff for them, right? Keep everything going. So the technologies that we're using for our backend is pretty standard, I would say. So it's Kotlin, Spring Boot, Postgres, Kafka. We have some Solid that's also a message queue, in case you don't know that. And the whole thing runs on AWS in the meantime. We have some, or we had, until today actually, we had some stuff running on Cloud Foundry as well, but we migrated that away into the public cloud. Not sure if you saw the talk of my colleague this morning about hybrid cloud. And then, of course, since we're a huge corporation and have lots of business folks, they all love Excel, right? So we work with that format as well. So not everybody might be familiar with Kotlin. So it's not hard to understand for Java developers, but I'm just going to say a few words about it. So you don't need a semicolon to end a statement. The new operator is not needed to create a new object. Nullability must be made explicit with a question mark behind the type. So if you have that statement up there, this is a nullable string. So if you would leave out that question mark, you would get a compile time error. So this really helps with null safety. Also, we have type inference. Java has that as well since quite a while, so that's nothing special. We have the public fields that come with accesses and mutators, and then we have data classes, similar to the newly added Java records, but Kotlin data class are a little bit more powerful. And then functions are more fun in Kotlin, right? Because you get to write fun all the time. And you can really have this shortcut with just, if it's just a one-liner, you can just add this, write this expression with the equal sign, and then it's really short and concise. Okay, let's go over some testing theory. So why would you worry about test code at all? Well, for us at least, we have more test code than we have production code. And you can see from that, testing is something that's very important in our project. And I think the reason for that is, of course, you want to make sure that you have a safety net if you release stuff, right? You don't want it to break. Also, it gives you freedom to refactor and everything. So the ratio on average in our systems is 60% more test code than production code. And why would we worry about writing good test code? Well, bad test code slows you down. It can be a real pain in the back, and it might even go so far that it doesn't catch your bugs. So overall, it's just a burden if you have test code that's badly written. And I was surprised yesterday. I'm not sure who of you saw the closing keynote of Steve Poole yesterday night. He actually said the code is not the thing, the test suite is a long-term investment. So I was actually surprised that he put so much emphasis on the test suite and thought it was more valuable than the production code, because production code, that changes over time, it evolves, but the test suite really gives you this safety net and captures your requirements. And so I found that really interesting what he said yesterday night. So desirable properties of tests. How do we want our tests to be? Well, first and foremost, they should be functional, of course. So they should tell us if something is broken. Then we also want them to be focused. So if a test fails, it would be nice if we would know fairly quickly what exactly is broken. And then we also want them to be reliable. We don't want to have flaky tests. Sometimes they're green, sometimes they're red. Oh, it's red, let's try run it again. Ah, yeah, now it works. Okay, all fine. Probably some of you know that, especially with end-to-end tests. Then we also want them to be robust. So we want them somehow orthogonal to our production code. So with that, I mean they should be like kind of separate. So we don't want to change our test suite when we change our production code, because then we lose that requirement specification basically. So we want to keep that separate, not to mess with our tests when we change production code. And then of course they should be fast as possible, easy to run. So you don't want to work through a huge manual to run your test suite. Okay, testing pyramids. I guess most of you know that already, so just very briefly. What this says is it basically relates to the amounts of tests you should have in your project. So you should have a solid base of fast unit tests, some a little bit less service tests, and at the top of the pyramid, there are the UI tests, of which you should have the least. And as farther to the top you get to the pyramid, the more expensive the tests get. and the more brittle they get. And that's why you have this shape where you should have a broad, reliable base of tests that run really fast. And then as you get to the top, it gets narrower and fewer. So this is, yeah, and don't take this too religiously. It's just a, the takeaways are basically have different kinds of tests for different granularities. So that's the one point. It doesn't make sense to test everything with just one kind of test. For example, if you've ever met people who are excited about UI tests, they want to test everything with UI tests. I think that's not the greatest idea. And then also the higher you get to the pyramid, the fewer tests you should have. Okay, let's talk about testable code. Testable code, I found this quote from Michael Feathers from his book, Working Effectively with Legacy Code. And there he writes, "It seems that the only ways to end up with an easily testable program are to write tests as you develop it or spend a bit of time trying to design for testability. There's a lot of hope for the former approach, but if much of the code in the field is evidence, the latter hasn't been very successful." So basically what he says there is you should write and grow your test suite as you go. So as you write your code, you should build up your test suite and not like, sorry, and not have your production code sit there forever and then 2 months later, yeah, we're gonna worry about the tests later. So write the tests as you go. And yeah, sometimes that can be like quite challenging because our code might not be very testable. And what's the reason for that? Well, mostly it's dependencies really. So if our code that we want to test has some nasty dependencies to other classes or other methods that are hard to deal with, or also like external dependencies like I/O, database, file system, Kafka, whatever, or even something universal like time, which you cannot influence really. And so how do we deal with these dependencies? Here I have an example of a fairly simple service. It looks pretty standard to most of you, I guess. So we have a service that has 2 dependencies. And then in the create bike profile method, we basically make a check. And then if that bike doesn't exist, basically we create it. And on the top right, you see that dependency graph, basically calling the repository, calling to the database. So that is what we have to deal with when we want to test that service. So how can we improve the situation? Well, there's this concept of seams. And again, Michael Feathers says, a seam is a place where you can alter behavior in your program without editing in that place. So you slice basically something away from your program and replace it, that part, with something else. And yeah, of course, you all know where I'm going, right? Subclassing, mocking, that's the kind of stuff I'm talking about. So using indirection to manipulate program flow. You can also do that with a C program. There, your seam would be a header file, and then you just swap the implementation underneath. So this is an example of subclassing. You basically derive a subclass from one of your from your dependencies, and then instead of passing the real dependencies into your service that you want to test, you just pass the stubs. And similar, it's with the mocks basically. Here I'm using Mockito, and you just say, okay, I want to create mocks of this type, and then Mockito does some reflection magic and creates those mocks. And yeah, as you can see, that seam in the lower right corner. So and because we now have a mock in place, we have cut off this dependency to the database, and we now can yeah, we no longer need the database to test our service. So far, so good. A colleague of mine made this quote, which I really liked. Like always, biggest issue is not with business code, but with test code. And I think he's exactly right. It's usually easy for us to write the business code. Whoa. But when it comes to writing test code, we struggle often. And so this is going now into the practical part. And this is basically how it's structured. So these are 5 big points that I'm going to talk about. First one, keeping your tests fast. So why would we want to keep our tests fast? Why would we bother? Well, slow tests discourage us from running them. We don't want to waste our time with waiting for tests. Also, they slow us down as developers and pull us out of the zone. Also, they inflate our build times. That might not seem like such a bad thing if you have your Jenkins running and does its job in the background. But the situation changes very quickly if you have a critical bug fix that you want to push to production and the clock is ticking. Right? Then you don't want to have a test suite that runs for 2 hours. You want fast feedback. Also, slow tests use more resources. This is the projected consumption of IT globally, and as you can see, it's going up. I think it's not so to such a big degree the fault of the tests, but anyway, we can save where we can. Just a side note. Okay, let's start with the first problem, slow test suite. So what could be the causes for this? Well, we might be doing unnecessary work. Also, we might use the application container excessively for testing. So I'm talking application container, I mean something like Spring. Or if you use, I don't know, it's been a while since I used Java Enterprise Edition, but yeah, you know what I mean. Also, we could be waiting, like spend a lot of time waiting for external systems, asynchronous code, to return the result. So, doing unnecessary work. Why does it happen sometimes? Well, we might need to, in order to test something, we might need to get the system into an initial state in order to test something. For example, you might need to populate a database with certain data, or you need to go through certain steps, and that might take time. Also, it could be that you're repeating the same work in every test method, initialization, checks, and everything. So I have an example here from our project where we needed an OAuth token to do some end-to-end tests. So we have keycloak, we call it to get a user token, and we do that before each test, and that's basically how that works. And that was very slow, but the solution here, luckily, was very simple, so you just avoid unnecessary repetition, right? And in JUnit, there are these annotations before all and before each. And in this case, as said, the fix was very easy. Don't use before each, so we don't need to get the token every time before each test. We just get it once before the test run. The validity of the token, in our case, is long enough to be valid for the run of the test suite. So we just get it once and then reuse it as we go and execute the test cases. So I'm just showing you the code from our project so that you know I don't make that stuff up, so it really happens. Also, testing everything with an application container was the second point. So it's very convenient to use Spring for everything, use Spring Boot test for everything, because you have that environment there, it gives you everything, and you can write your tests very easily, but can slow your test execution time down quite a bit. So these are some numbers I gathered while ago, and yeah, of course, take them with a grain of salt. It's just my machine and my project, so they might differ heavily from your numbers, but it's just that this kind of the relation. So you see that the plain JUnit test is very fast, whereas the Spring Boot test is very slow. That's basically what I want to say here. So the solution to just keep that down a little bit is to ask yourself, when you write a test with the application container, okay, does it really need to be the Spring Boot test application, or can I maybe use the web MVC test or data JPA test annotation? Is that enough? Or do you really need the whole thing? Or it might be even possible to use the plain JUnit test. But I want to really emphasize that you should only do that if that's possible, only if you waste time. So don't cut corners and sacrifice the quality of your test suite for speed. I'm just talking about wasted time here. So if you need to use the full Spring Boot container, then do it, of course. One example I have here is validation testing in Spring without the container. So let's assume you have a class person which has a bunch of fields with some validators on them, and then you want to test those validators. Then you could either do that with a Spring Boot test, or in this case it even works with a plain JUnit test. There is this validator factory in Spring. You can instantiate a validator with that factory, just pass the object into it, and then it will give you a list of validation results, and you can check if everything was fine, basically. Okay, last one. Waiting. So that's actually a nice one. Waiting. Yeah, we could be waiting for external systems, especially if you have end-to-end tests, if you're using Kafka or something like that. You might be familiar with that. Also, if you have some asynchronous code, it's not always clear when the result comes. So the first naive solution, if you need to wait for something, is of course do a fixed wait. Wait a couple of seconds, couple of milliseconds to just guess how long it might take. Then you add some safety margin on top, and then you hope is all fine. But the problem is really to how long do you wait for that result, right? If you wait too long, you waste time. If your wait time is too short, it becomes unreliable and flaky. And yeah, you have a similar situation with local asynchronous code. So what we found is it helps to use polling instead of fixed wait if you need to wait for something. So that's faster and more robust. Faster because you only wait the amount you really need to wait, and more robust because you can give the whole thing a longer grace period, because if you don't, you don't always spend that time, so you can make the timeout a little bit larger, so to say, just to be more graceful if Jenkins has a bad day or something. And if you have like local asynchronous code, it might be possible to leverage some of the synchronization classes in Java util concurrent. For example, countdown ledge can be used for that. If you have a lot of that kind of code, you probably know that book, Java Concurrency in Practice. It's really a good book. I encourage everybody to read that. So again, from our project, waiting for message processing from a queue will be the next example. So what you see here is a part of a test case. So at the top, we're sending a stop message, then we're doing a fixed wait, and then we're checking for a result. So what's happening here is we ingest trip data from the bikes, and then these trips are always ended with a stop message. So if we get the stop message, we know we have all the data and the trip can be processed. So we process that. And then once the processing is done, we offer it on a web API. And that's basically what we're testing here. So as you can see, every time we wait 3 seconds, no matter if processing takes 10 milliseconds or maybe it also takes longer, but it's always the same amount of time. And this was annoying for us, so we just came up with this wonderful idea of polling. So now we just poll every 100 milliseconds, and as you can see, we can also allow ourselves a bigger grace time because we don't always spend that. Most of the time, we'll probably get the result within 100 milliseconds. And if Jenkins has a bad day, we can also allow ourselves to wait like for 7 seconds or so. It's not a big deal. So that's good. Of course, many of you will now say, well, that code is really like hard to read and quite horrible. Yes, hold that thought. We're getting back to this later. Okay, keeping your tests maintainable is the next big section. Yep. If you feel like your tests are a maintenance burden, like it's really painful to work with them, and they slow you down if you change something in your production code, and then there's this huge list of compile errors that you have in your test suite, and it's like holds you back, then yeah, maybe you have a lot of duplicate code. That could be one reason. Your tests might be brittle. Of course, these lists are not exhaustive, but these are just two I'm going to talk about. So if you have a lot of duplicate code, you probably know that. Have you ever had an object that is very widely used in your system, and you copy that everywhere, and then you introduce a new parameter or something, and then, oh my God, I have like, I don't know, 70 compile errors or however often you use that. Also changing parameter types, change of usage patterns, this kind of stuff, and then you have to fix it in a whole bunch of places. This is really annoying and yeah, feels like a drag. So the intention behind that is actually good, right? You want to keep your test code separate from your production code. So yeah, you want to avoid like tying those close together, and you just want to keep them separate, that changing your production code doesn't influence your test suite. And that's a good thing. But that's not a reason to throw all your good habits out of the window. So you all know the dry principle, do not repeat yourself, and that also is true for, or that also is valid for test code. Yeah, and everybody knows methods and stuff, but it's actually quite surprising, yeah, how few people use them when they write their test code. I've seen this in quite a lot of places. So yeah, it's just interesting. I don't know why that is the case. But there are actually two helpful patterns you can apply here. One is a test object factory, or the other one is test object mother. So the difference between those two is factory just creates a bunch of very generic objects, whereas a test object factory creates very specific objects. It's more like creating personas, if you will. So in our project, for example, this could be bikes with a very specific configuration, a mountain bike, a race bike, or something, or it could be a very specific type of user where you would also know maybe the name and their age and stuff, and you could also talk about these specific personas in your project. So it could also be part of your vocabulary. So just a factory doesn't know its products, but a mother knows their children. And this kind of analogy is it. But basically, it does the same thing. It creates an object. So let's start with so I'm going to show you an example of the test object factory. So we have these writer profile objects. They have a whole bunch of properties. And now, we use that quite a bit in our test code. I'm not sure I've written 30 times, but I'm not sure, maybe it's also 60 times or more. But we had code like this quite a lot, copied and pasted all over the place. And but the funny thing is, we also don't need all these parameters really for our tests, right? So what can we do about it? We extract a factory method and just as parameters for the factory method, we just pass the parameters we really care about. In that case, you can see it's mainly the IDs we care about in our tests. And the rest we just fill in with some random values that don't really, that are not really important for our test. And then we can create the object in a really nice and simple way. So at the top, you see the old code, like with all that bunch of parameters that are not important for our test, but are there anyway. So this creates a lot of noise. It's way harder to understand. And at the bottom, you see, okay, this is really simple. It's just one short line. I can see very quickly what that does. So pretty handy, I would say. Then also next problem, brittle tests. So you change something over here falls over. Not sure if you had this situation before. It's quite surprising sometimes. Well, the solution for this is basically to keep your test surface small. So don't use a whole bunch of assert statements in your tests methods that are not really related. So sometimes it's tempting to test more than you should because you have the result already. So I can test this stuff. I only would like to test this aspect, but now that I have the result already, let's just test more of it, right? Then I don't have to write that code again. So maybe you also do that to avoid copy and paste, but it can bite you later on. So make sure to just focus your tests on your test methods on certain aspects. If you want to test different aspects of that method call, just use a different test method. Also, don't over-test. For example, if you want to check that a method throws an exception, do you really need to check for the exception message? Is that like important, or is it enough to just check for the exception type? And then also, make use of helper methods. Again, to just keep your code contained and in one spot. So if something changes, you have that all in one spot. And if that doesn't work anymore because your domain changes or so, you just split that up and then create a separate helper method. But it's way easier if all of that is in one method than littered throughout your code base. Keeping tests readable. Anybody of you know this concept of write-only code? Perl developers might be familiar with it. So this is actually a skiing program. This is quite intense. But to be fair, it's from a context to write obscure code. But yeah, of course you don't come across such unreadable code, but you know what I mean, right? So some tests that you see are really hard to understand, so you have to look at them really hard, and then it's quite time consuming to understand what they're actually doing, especially if your domain gets a little bit complexer, more complex. Well, causes for this could be you have a lot of noise in your test, and also unclear naming might be a cause for this. Yeah. If you have a lot of noise, what I mean by that is basically there's a lot of stuff going on, like we had earlier in that example where we created the object with a lot of parameters that were not actually significant for our test. So that's what I mean with noise, and that makes it hard to understand. Also, our intent, the intent of the test might get lost in technicalities. Yeah, we'll see an example of that. For example, if you look at this one, it's not super hard, but it's not like, okay, I know right away what it's doing. So what can we do about it? Well, again, helper methods could help you to extract stuff and give it a clearer name. Also, you could, if you have some technical stuff in there, we'll see an example of that. You could also put that into helper methods, encapsulate it in there, and then hide that basically. And then it's always a good thing to ask yourself, how easily would I still understand this code after 6 months? I mean, that's of course the same for production code, but I have the feeling people don't forget, or people forget to ask themselves this question for the test code. Okay, again, an example from our project. We've just seen that. So, yeah, rest assured, probably everybody is familiar with it. But you can also have it quite nice and simple, right? If we put these rest assured calls into helper methods and we have this method on top, we see right away what's happening. We create a bike, we delete a bike, and create it again, and just see if that works. So this is way easier to read, and it is very easy to do that, but it's surprising, and that's why I'm showing these examples from our project. It's surprising that like so few people take advantage of these like simple measures to make your life easier. We came across this beautiful example of the polling earlier, where we replaced the polling, the fixed weight with this polling code. And hopefully everybody went like, ugh, what kind of code is this? So again, here, one thing to improve the situation is to introduce a helper method. So check has summary for activity. We want to check, that's a little bit our domain, but we want to check that that we have a summary for a certain activity. And then we introduce this method run with retries. So we basically extract this technicality of polling into a separate helper method, because we don't only need that in this test case, but we need that in other test cases as well. Everywhere where we have like this async Kafka stuff, and we need that for end-to-end tests, it's very helpful to do. So the way it works, basically you have an initializer, initial call, and then you have a probe method that checks continually for the results, and then you have a result handler that checks, okay, is the result what I would like it to be. Can make this even shorter by, again, extracting stuff into helper methods. Or also, some of you might know this, you can also simply use a library, because libraries are really great in encapsulating technical stuff that you need to do over and over again. That's one library that's there for Java, at least. I'm not sure actually which other languages it also covers. Okay, keeping your tests readable still. Nebulous test method names can be annoying. So this is the case, like you have a failing test, and then you see that in your Jenkins job, and you see that red method, and you think, okay, what is this testing? And you have no idea what's actually broken, because the name could be something like throw illegal state exception, and you're like, whoa, great. This doesn't give me any information what's actually wrong. So if you come across this, you might ask yourself, okay, which method should throw an exception, and in which circumstances? And this could give you a valuable head start to better assess the situation and the severity of that test failure. And again, the fix for this is also really simple. Just use better naming for your test methods. So in Kotlin, you can use the backtick, and then you can also have white space in your method names. And one pattern I found really useful is this, or I find really useful is this: my method should do this and that when such and such. So it's a little bit like the given when then. And then you could turn this name that you see at the top, should throw a legal argument exception, into sync check and event types. So that's the method under test. Should throw a legal state exception when given invalid events. So if that method fails, you know right away kind of roughly what's going on. Next part, keeping your tests valuable. So if you have the problem that it's not clear what the impact is of test failures, then causes for this might be test blindness or lack of problem indication. And let's explore that in more depth. So this is particularly nasty. So you have a bug, and you even have a test case for that, but your test case didn't catch it. And it's we had this just a couple of weeks ago. It was quite interesting. So a developer basically used copy and paste because we extended some functionality, and then the developer used copy and paste to write test methods for that new functionality, but unfortunately they forgot to adjust some variables. So what the new tests were actually testing was the old stuff. And you have a test method, but it doesn't test the right thing. Solution for this: test your tests. So I don't mean here with write more unit tests that test your unit tests, but if you have a test that tests something more complex, or you just had a bigger session where you maybe did a lot of copy and paste and you're not sure if you caught everything, then it might be worth your time just changing the production code and see if the test actually fails. Because sometimes it happens. I also had that you write a test and then you change production code and you see, oops, the test doesn't fail. Then you know right away, okay, my test doesn't delivers actually no value. It's useless. And I think that quote here, never trust a test you haven't personally seen fail, I think that's very true. So yeah, I find that a very valuable technique to have in your tool belt, to just go ahead and try to break your code and see if your tests catch it. The lack of problem indication. So I know something broke, but I don't know what. So it's similar to the nebulous naming we had earlier, but this time it's more targeted towards the error message itself. And running out of water. One thing we can do about it is just keeping our tests focused. So one assert at a time, or a group of related asserts at a time. So yeah, as said earlier, just one aspect per test method. Don't mix and match like crazy, because then that's going to be very confusing, and you're just going to spend more time debugging when that test fails, because it's harder to see why it failed. And the other thing is a little bit different, the user focus. So if you write a test, try to break it and then see if that error message is helpful for you, whether it actually helps you knowing right away what the failure is without going into the code. So for this, I have this example of this validator I showed earlier. So maybe you remember we had this person class with these three properties: first name, last name, age. And there were validators on the name properties. So they should be between 3 and 255 characters, I think. And so here we turned John Doe into John Yo. So he became a rapper. And now the violations should kick in, and then our test should tell us that something is wrong. And also it works, but it just, it's not really helpful. It tells us, okay, expected true, but was false. If I just see that in Jenkins, I probably don't know what's wrong. Now I can improve the situation, and I can add a message. So in JUnit, you can always add a message to your assert statements. And that makes it a little bit more helpful, right? So here you could add the message that the validation failed for a valid person. Gives you a better idea what's happening. Or you could even go the extra mile and make it really helpful. In this case, we go through the violations, we get return from the validator, and create a list of error messages out of it. And then we compare this list of error messages with apparently it's a set of error messages with an empty set. And our expectation would be that if everything is good, our set of error messages is also empty. But in case there is an error, we now get the failure message, the validation message right in our failure message. So I know right away, okay, the problem here is the last name property, and the reason why it failed is because it's not between 3 and 255 characters. Yeah, and I really love it if I see like these clear messages. That's why I put the heart right there. Keeping your tests safe. Next big block, but very, very short block. So sometimes in your tests, especially end-to-end tests, you might be calling external systems. Those systems might have side effects, like sending emails or invoking payments. So we need to take care that we don't do the wrong stuff here, right? That we don't talk to the wrong system. And for that, you can have environment-specific configurations. In Spring, that's really easy to do with the Spring profiles. Application-dev.properties, application-prod.properties, and so on. Probably most of you know that. Here, make sure that your fallback file, so the application.properties, has safe settings. So don't put like production systems in your default application properties, because if you forget to add that profile in your test environment, or if there's a bug in your CI/CD pipeline or something, then it will fall back to that setting, and you don't want to, like, I don't know, delete your production database or something like that. Also, something that not everybody might know, there is actually an RFC for some top-level domains that are explicitly reserved for testing. So .test, .example, .invalid. And we made use of that quite a lot when I worked for an email marketing company. Of course, there it's very important to not send like real people email that haven't subscribed to it, because that will reflect very badly on your company. So we always made sure that if we had a list of test recipients, our test data was always, these addresses always ended with .invalid, not to, like, in case we misconfigured something, we wouldn't send it to anybody, but it would just like go nowhere, basically. Yep, and that's basically already it. Summary: don't waste resources, especially not your developers in the zone time, by making them wait unnecessarily. Avoid duplicate code to not make your test suite become a burden. Avoid brittle tests by being focused. Use helper methods to hide technicalities and reveal intent. So you've seen that they came up again and again. It's such a simple technique, but it's heavily underused, I would say. Choose clear naming and write your tests with the user in mind, which is your coworkers or your future self. And with that, your tests are code too. Keep them solid, keep them clean. And that's all I have. Thank you very much.